Bismillah, this is Dr. Magda Talib Al-Hinai from the Department of Mathematics and Statistics, Sultan Qaboos University, presenting functions and graphs. This presentation is exclusive for the Independent Learning Center at Sultan Qaboos University. We start with the definition of a function. We mean by a function a rule that assigns to each element in this x in the set A one and only one element f of x in the set B. And we call the set of all input elements the domain of the function, while the set of all output elements, we call it the range of the function. In front of us, we see two examples. One describes a function, which is having element x1 and element x2 going to the same image, y. To the right side, we see that element x1 goes to two images, y1 and y2. So this does not describe a function. Here are some examples on functions. We will give you the function f of x and we will ask you to evaluate f of x at certain values of x. Then you will be asked to graph the function and find its domain and range. We start with the first example. F of x is equal to x squared. This function takes the element x to its square. Part A, evaluate f of x when x is equal to minus 2, x is equal to 0, and x is equal to 2. Part B, graph the function. Part C, find the domain and the range of the function. So we start with part A. What is f of minus 2? We simply plug in minus 2. We take minus 2 to its square, so this is 4. What is f of 0? We substitute for x 0, and then we square the 0, so we get 0. So f of 0 is equal to 0. Finally, f of 2 is equal to 2 squared, so this is also 4. In part number B, in order to graph the function, we need to make a table. In this table, we assign values for x and we evaluate the corresponding values f of x. So we take the table from minus 3 onwards to 3. So when x is minus 3, we get f of x 9. When x is minus 2, we get f of x 4. When x is equal to minus 1, we get f of x is equal to 1. When x is 0, 0 squared is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9. And we take these points and we plot them in the xy plane. As we see in front of us, we get the U-shaped curve, y is equal to x squared. This curve, as we see, it's open upwards and having its vertex at the origin 0 and 0. From the curve in front of us, we see that the domain of this function is all real numbers, while the range is the semi-closed interval 0 to infinity. Another example, given f of x is equal to square root of x. A, evaluate f of x at x is equal to 0, x is equal to 1, and x is equal to 4. B, graph the function. C, find the domain and the range of the function f of x equals to square root of x. In part A, we plug in the values 0, 1, 4. What's the square root of 0? It is 0. What's the square root of 1? It's 1. What's the square root of 4? It's 2. So we move to part B. Part B, in order to graph the function, again, we need to make a table. And this table, as we see in front of us, we have the upper row for x, the lower row for the square root of x. So we take values from 0 to 5 and we take the square root of each of these values and we evaluate the square root of 0 to be 0, square root of 1 to be 1, square root of 2 to be square root of 2. You can use the calculator for square root of 2 and also you can use the calculator for square root of 3. Square root of 4, we all know it is 2, and square root of 5, again, you can use the calculator to evaluate it. And then we move to the xy axis and in the xy plane, we plot point by point and we get the curve in front of us. As we see, the domain for this function is the interval closed from 0 up to infinity. Okay, and so is the range also. It's the semi-closed interval 0 to infinity. The following example, we give you f of x to be equal to x. Find the f of x at x is equal to minus 10, x is equal to 0, and x is equal to 9. Then graph the function, find its domain and range. we plug in the values given for x, so f of minus 10 is minus 10, f of 0 is 0, and f of 9 is 9. In order to graph the function in part B, we need to make the table again. We take values from minus 3 to 3, and we evaluate the corresponding values for f of x as you see in front of you. Then we take point by point and we go to the xy plane to sketch the graph. As we know, the curve of f of x is equal to x is the straight line passing through the origin, and we see it in front of us. The domain for this function is all real numbers, and so is the range. Here we have an example for f of x to be equal to x cubed. We also ask you to evaluate f of x at x is equal to minus 2, x is equal to 0, and x is equal to 10. Then graph the function, and then find its domain and range. So first we start with the minus 2. What's f of minus 2? It's minus 2 cubed, so it is minus 8. Then f of 0. 0 cubed, this is 0. F of 10. 10 cubed, this is 1000. In part B, we ask you to graph the function, so again you need to take values for x and evaluate the corresponding values for f of x, make a table, and then plot the graph point by point in the xy plane. We start in this table from minus 3 to 3, and then we go on cubing. What's the cube of minus 3? Minus 27. Minus 2 cubed? Minus 8. Minus 1 cubed is minus 1. 0 cubed, it's 0. 1 cubed, it's 1. 2 cubed, it's 8. 3 cubed, this is 27. And then we go to the xy plane and plot our points point by point to get the curve in front of us. Now, the domain of this function, as we see, is the set of all real numbers, and again, the range is also the set of all real numbers. Here comes the absolute value of x. We ask you to evaluate the absolute value of x is equal to minus 2, 0, and 3. Then graph the absolute value of x, and then find its domain and range. So when x is equal to minus 2, what's the absolute value of minus 2? Yes, this is 2. And then for 0, absolute value of 0 is 0. For 3, absolute value of 3 is 3. We go to part B of the question to graph the function. Again, we make a table from minus 3 to 3. Say you can do it from minus 5 to 5, from minus 4 to 5. It's all up to you. And then we evaluate the corresponding values of f of x. What's the absolute value of minus 3? 3. Absolute value of minus 2? It's 2. Absolute value of minus 1? It's 1. Absolute value of 0? This is 0. Absolute value of 1 is 1. Absolute value of 2? It's 2. Absolute value of 3? It's 3. We take these points point by point and we go to the xy plane and we sketch the graph. We all see in front of us the graph of the absolute value of x. This is the V-shaped graph. It's open upwards, having its vertex at the origin. And as we see, the domain is all real numbers, while the range is all values greater than or equal to 0. So it's the semi-closed interval 0 to infinity. Let's give you some remarks. The first remark: the domain of any polynomial is the set of all real numbers. For example, we give you a polynomial of degree 4, f of x is equal to x power 4 plus 2x plus 5. This polynomial function is defined for all real numbers. The second remark: the domain of f of x is equal to the nth root of x depends on n. So if n is an odd number, then the domain is all real numbers. For example, I say f of x is equal to cube root of x. Cube root of x is defined for all real numbers, positive, negative, and 0. While if n is even, then the domain is the set of all real numbers that makes what's under the root greater than or equal to 0. For example, if I say f of x is equal to square root of x, then this is defined only for all real numbers greater than or equal to 0. The third remark: the domain of a rational function. This will be the intersection of the domain of the numerator and the domain of the denominator, provided that the denominator is not 0. For instance, if I say f of x is equal to x squared over x squared minus 1. What's the domain of the numerator? All real numbers. What's the domain of the denominator? It's a polynomial, also all real numbers. But f of x, being numerator and denominator, will have a domain which is all real numbers except what makes the denominator 0. So the domain of this function will be all real numbers except plus or minus 1. The vertical line test. We use this test to decide whether the graph given to us describes a function or not. So we simply draw any vertical line. If this line cuts the graph in more than one point, then the graph does not represent a function. And here in front of us, we see the graph to the left. If I draw a vertical line, it will cut the graph to the left in more than one point. So this is not a function. While the graph to the right, if I draw any vertical line, it cuts the curve in only one point. So this represents a function. Now we present the definition of odd and even functions. Odd functions. We mean by an odd function a function satisfying f of minus x is equal to minus f of x. For example, the function f of x equals x cubed plus 5x. This is an example of an odd function. Simply remove each x and put minus x. So you have f of minus x is equal to minus x all cubed. This is equal to minus x cubed plus 5 times minus x. This is equal to minus 5x. So our function now is minus x cubed minus 5x. Can we take a minus common factor? Yes. When you take a minus common factor, you will have minus open bracket x cubed plus 5x. What's inside the bracket is simply f of x. So we prove that f of minus x is equal to minus f of x, which means that the function given is an odd function. For even functions, here we define it. We mean by an even function a function that satisfies f of minus x is equal to f of x. For example, we have f of x is equal to x power 4 plus 5x squared. This is an even function. Simply, if you plug in for each x a minus x, you will arrive at f of x. Let's try. So we see f of minus x is equal to minus x all power 4 plus 5 multiplied by minus x all power 2. Minus x power 4 is simply x power 4. And minus x all squared is simply x squared. So here we have x power 4 plus 5x squared. This is f of x. So we have shown that f of minus x is equal to f of x, meaning that the given function is an even function. Here we have an example which shows that not all functions should be either even or odd. So show whether the function f of x equals x cubed plus 5x squared is odd or even. We start with evaluating f of minus x. We plug a minus x for each x. So I have minus x all cubed plus 5 times minus x all squared. Minus x all cubed, this is equal to minus x cubed. But minus x all squared, this is equal to x squared. So we arrive at minus x cubed plus 5x squared. This is not the original function we had. This is not equal to f of x. Therefore, the function is not an even function. Now, let's evaluate minus f of x. So I take f of x and I multiply it by minus sign. I get minus x cubed minus 5x squared. And this is also not equal to f of minus x. Therefore, the function is not an odd function. Accordingly, it's neither odd nor even. And finally, we present a remark that an even function is a function which is symmetric with respect to the y-axis, while an odd function is a function which is symmetric with respect to the origin. And in front of us, we see two curves, each representing, one is representing an odd function and the other is representing an even function.